I'm Liu Xilin from Group 3, and my teammate is Sungyin Qi. Our topic is material requirements planning. I will present the section of introduction, BOM structure, and finally, I will explain the example 2. So the first part, introduction. What is MRP? MRP is a calculation tool used to plan the material demand volume and the time of demand. It is mainly used for handling dependent demand materials, such as components and raw materials. And the objective is an MRP system to determine the quantity and timing of material requirements and to keep priorities updated and valid. When to use MRP? In job shop production, complex products, and assemble to order environments, and discrete and dependent demand items. And three core components from MRP. First, master production schedules, BOM, and inventory records. So part 2. As we can see, the image shows a skateboard, which we can consider as level 0. And it includes one board, 2 trucks, 4 wheels, and 8 screws. Each wheel contains the next level. Level 2 consisting of 1 tire, 1 rim, and 4 screws. First, we draw the corresponding product structure tree and label the required quantities. For example, A equal to 1 plus 1, where the first one, means 1 unit of x. 1x needs 1a, 1 unit of a, and the second one means we are producing 1x. Similarly, B equal to 2 plus 1, where 2 means 1x needs 2b, and the 1 is again the number of x. So following the logic through the product structure, we can calculate 1x will require 1a to be for C 24D, because 1x need 8D, but C includes 4D, so the level 2D equal to 4 plus 4 equal 16, and the level 1D 8D, right? So finally 1x will require 8 plus 16, so we 1x require 24D, and 4e and 4f. The example 2, manufacturing company produce a final product. Okay, product B. Each B consists of 2 units of component A, 3 units of component B. Further, each A is made of 2 units of part C and 1 unit of part B. Part D, each B is made of 1 unit of part E and 2 units of part F. So we also draw the production constructor tree. Okay, we calculated that 1p. Okay, so for the same method of calculation with the just the V side, 1p will require 2a, 3b, 4c, 2d, because 1p need require 2a, right? and 2A, 1A require, okay, the first one means 1A require 1D, right? And the 2 means, where the 2 means the first level, the original level 0, 1P need 2A, so 1P need 1 plus 2 equal 2D. Okay, 1P also require 3E and 6F. The same calculation, right? Importantly, I want to explain the wait. Now I want to emphasize the second question: how to calculate night requirements when inventory is considered. Okay, the question is determine the night requirements and take into account the current on-hand inventory. We simply subtract the on-hand inventory from the gross requirements we calculate from the product tree. For instance, 8 units of P require 6 units A, but since there are 4 units of A in inventory, we can see in the photo, we had 5 inventory A, 2B, 20C, and so on. So using this, so the night requirement for A is actual 8P, right? 1P need require 2A, so 8P require 2 plus 8, 16A. But we have just I mentioned A have 5 inventory, so actually we the net requirements for A is equal is 16 minus 5 inventory equal to 11. So using this method, we can determine that for 8 units of P, we need 8P will require 11A, 22B, 12C, 1D, 16E, 13F, right? Okay, the next part of the presentation will be delivered by Yuki, TV. I will finally explain the example 2.
Okay, my name is Sangyuan Yu. Next is my presentation. The part 3 is MRP processing. MRP processing takes the end item requirements specified by the master schedule and explodes them into time-forced requirements for assembled parts and raw materials using the bill of materials of state by lead times. The components of MRP mainly consist of 6 parts: grossing requirements, schedule receipts, projected on hand, night requirement, planned order receipts, and planned order releases. Look at this table. This table is the one needed for the conclusion. Next, I will provide a detailed explanation of each component. I will take part C as an example and explain the key date. Firstly, gross requirement. The gross requirement is total expected demand for an item or material in a time period. From the question, it can be seen that the total quality of Part A is 50 units, with 10 units on hand. Therefore, Part A only needs to produce 14 units, and one Part A requires the combination of 3 Part C. So, Part A's grossing requirements is 3 multiplied by 40 equals 120. Secondly, schedule receipts. The schedule receipts is the quality of material already ordered and expected to be received at a future time. Comes to exacting purchase orders or production orders. But in this question, no date was found. So, the schedule receipts is 0. The next part is projected on hand. The projected on hand is expected amount of inventory that will be on hand at the beginning of each time period. And project inventory on hand for current period is equals to the planned receipts for previous period minus the net requirements for previous period plus the schedule receipts for current period. So, as can be seen in the table of the question, there are 20 units of Part C, and there are no other date. So, the project on hand is 20. The next part is net requirement. The net requirement is represents the accurate quality that needs to be newly purchased or produced. The net requirement is equals to the grossing requirement minus the projected on hand. And if the result is 0 or negative, no order is needed for that period. Look at this table. In this table, we can see that the grossing requirement is 120 units. The projected on hand is 20 units. According to the calculation, the net requirement is 100 units. The next part is planned order receipts. Usually, use the as needed supply policy or specific batch size rulers are followed. This problem use L4L policy. In L4L policy, the planned order quality each time is equals to the net requirement. We know that the net requirement is 100. So, according to the calculation, the planned order receipts is also 100. Next part is planned order releases. To solve the question, we need to take the lead time into account, which is usually given in the problem. Look at this picture. From the question, it can be determined that the lead time of C is 1 week. So, the reservation should be made in the 6th week. The part 4 is MRP example 1. Look at this picture. Example 1 is the symbolic issue of CD. According to the information in the question, we can get a product structure tree as shown in the picture. Next, we are going to make a calculation based on the date. Look at the first table. The first table is cabinet top. We can see that one CD cabinet only needs one cabinet top. So, the grossing requirement is 100 units. The projected on hand for 1 week is 120 units. The 120 units is inventory. And because the grossing requirement for 3 weeks is 100 units, the projected on hand for 3 weeks is 120 units. According to the calculation, the project on hand for 4 weeks is 20 units. And in 6 weeks, the planned order receipts is 144 units. The night requirement is 80 units. According to the calculation, the projected on hand for 7 weeks is 64 units. Due to the FOQ policy and the cabinet top's lead time is 3 weeks. So the planned order release for 3 and 6 weeks is 144 units. Look at the second table. The second table is shell. We can see that one CD cabinet need 4 shell. So the grossing requirement is 400. Because the shell has no inventory. So according to the calculation, the projected on hand for 1 week is 0. According to the calculation, the night requirement is 400. Due to the shell use the L4L policy, the value of the planned order receipts for the 3, 6, and 9 weeks is 400. Due to the lead time is 2 weeks, so the value of the planned order reserve for the 1, 4, and 7 week is 400 units. The next example will be explained by Liu Shilin.
In example 2, a computer workstation is given. Each workstation includes 2 monitor arms and 1 keyboard tree. Each keyboard tree contains 3 adjustable legs. The lot for lot rule is applied in this case. And the first step is to draw the corresponding product structure tree and label the quantity relationships. According to the given information, 100, 150, and 200 units of workstation need to be produced on day 4, day 5, and day 7. Because there is no inventory or any scheduled recipes, so the night requirements for those days are also 100, 115, and 200 based on the lead time orders. For 100, 115, 200 units should be placed on day 3, day 4, and day 6. Since one workstation requires 2 monitor arms, the demand for monitor arms, so the demand for the gross requirements for monitor arms on day 3 is 100 multiply 2, because just I mentioned before, one computer workstation needs 2 monitor arms, right? So there's gross requirements is equal 100 multiply 2 equal to 200 units. Yeah. So correspondingly, the day 4 is required 300, and the day 6 required 400. And the schedule, the recipes are fully used on because day 2 have 100 unit schedule recipes, right? So the day 3's night requirements equal 200 gross requirements minus 100 schedule recipes, so equal 100. And day 4 and day 6, there are not any schedule recipes and project on hand, so the day 4 night requirements is equal 300, and day 6 night requirements is 400, and based on the lead time, so I should place the order 100 units for day 3, and extra 300 units for day 4 on the day 2. So 100 plus 300 equal 400 units. And on day 4, we order for the 4 units required on day 6 should be 400 units required on day 6 should be placed on day 4. Yeah. Since each workstation requires only one keyboard tree, and the gross requirements on day 3, day 4, and day 6 are 100, 115, and 200 units respectively. There is an initial inventory 6 units, so the net requirements on day 3 is 100 minus 16 equal to 40 net requirements. With that, remaining gross requirements stay the same because there are no the original project on hand is already finished. So the day 4's net requirements is equal to 115, and correspondingly, the day 6 net requirements is equal to 200. So based on the day 10, 40 units should be placed on day 2, and 115 on day 3, and 200 units should be placed on day 5. And finally, according each keyboard tree requires 3 adjustable legs. So the demand on day 2 is 40 multiply 3. Yeah, sure, 3 equal to 120. Similarly, method calculations, the same calculation method, the 450 units on day 3 required on day 3, and the 600 units should be required on day 5. And there is an initial inventory of 120 units, so the net requirements on day 2 is 0, and no order need to be placed. Therefore, an order for the day 3 need 415 net requirements, right? So we should, based on the lead time, we should be placed we should place 415 units on day 1, and order 600 units on day 2. Okay, that's my part of the presentation already finished. The final section will be presented by Sangyin Qi.
Okay, the part 6 is MRP output. The MRP output is mainly divided into 2 parts: primary report and secondary report. The primary report includes planned order releases, and change the planned order. The secondary report includes performance control report, plan report, and abnormal report. The final part is a conclusion. Look at this. This is a conclusion of our MRP section. Okay, our presentation is over. Thank you.